All right, now let's take a look at what happens when our bases are different, but our exponent is the same. So before, when our bases were the same, we kept the base the same and added the exponents. Now this is going to be a little different because I can't keep the base the same because I have two different ones, but I can keep the exponent the same. So here's what's going to happen. We're going to take this 2 to the third and we're going to expand it. 2 to the third looks like 2 times 2 times 2. Then we've got 5 to the third, which would look like 5 times 5 times 5. So if I hit the equal symbol, then it leaves it like this. Now here's how this works. If you notice, there's the same number of 2's as there are to 5's. I can group 1 2 with 1 5. And I can do that. If I do that one time, that takes off the first 2 and the first 5. I can do that 2 more times. So I know that 2 times 5 is 10, and I have 3 of those groups. So 2 times 5 shows up once, shows up twice, shows up 3 times, so it's going to be 10 to the third power. So essentially, we went from same exponent stays the same, and then all we did was 2 times 5 to get 10. Same thing's going to happen here. 5 times 5 times 6 times 6. Oops, I don't want that, so I'm going to come back over. I'm going to come back in here. I'm going to put the equal sign so it doesn't change it. Then I also know that 5 times 6, because I can put those together, and I can put those together 2 times, equals 5 times 6 is 30 to the second power. This last one, 10 times 10 times 10 times 10 times 2 times 2 times 2 times 2. I can put each of those 10s with a 2, and I would have 4 groups of that. And 10 times 2 is 20 to the fourth power. Now these we're not going to do. Okay, because I'm going to do it over here. But what I want you to notice is that when we have 2 powers that have the same exponent but different bases, all we did was multiply the bases and keep the exponent the same. There's our rule. So how that looks algebraically, to multiply the bases, I'm going to do A, B, because that's what A times B looks like in algebra. Shift 6 to the n power. That's how I finish that rule. So here's what happens when we do some practice problems. On this one, different bases, same exponent. So rule says multiply the bases, 6 times 8. Keep the exponent the same. Because I know I can do 6 times 8, I'm actually going to do that. 6 times 8 is 48 to the 8th power. That's it. You'll do the same thing for these. Now, when you get down to this last one, 4 to the 5th, or 4 to the 4th times 5 to the 4th times 2 to the 4th, same exponent. All I have to do is multiply all 3 of those. 4 times 5 times 2, and that's going to raise up to the 4th power. Multiply 4 times 5 is 20, times 2 is 40, so the 4th power is how that would look. And then this last one, you're just going to have 2 different powers as your answer. The 7 to the 3rd can't get combined with the 8 to the 4th because they don't share the same exponent. So I have to find another power that's a 3. 7 to the 3rd can go with 2 to the 3rd. I can put those together. 7 to the 3rd times 2 to the 3rd. And then that leaves me with multiplying. Why is that moving so small? 8 to the 4th times 2 to the 4th. And then all I do from there is simplify each of those. 7 times 2 is 14 to the third power times 16 to the fourth power. So finish this slide, go back to Echo, turn in slide 11, and then do the exit ticket for same exponent, different bases.